Alright, let's do some practice problems on simple harmonic motion. Number 7. You've got two oscillating systems, a spring, a weight on a spring, and a pendulum, and they say, what would happen if you double the mass of the pendulum, double the mass of the spring on the mass on a spring? Well, let's take a look at the equations. The mass on a spring, of course, you double the mass, you're going to double something underneath the square root. So what will happen is if the right side gets bigger by radical 2, the left side gets bigger by radical 2. Let's look at the other equation for the pendulum, and there is no mass in that equation, so the period of the pendulum remains constant, and the mass on the spring changes by radical 2. Instead of t, it's radical 2 times t. Object undergoes simple harmonic motion. What its position is 0.1 times sine 4 pi over t. What is the period of the oscillation? So this is the general formula for if your x position is given by sine, which means that your x position starts out at 0 because sine starts out at 0. This is the general formula where a is the amplitude, which is not what they're looking for, but t is the period. So 2 pi over t times t is the general formula. That goes in the trig. So this is 4 pi times t. So we look at that. 4 pi equals 2 pi over t. Let's go down here. So that means that 2 pi over t equals 4 pi. Pi cancels out. And 2 over t equals 4. Cross multiply. Make this 4 over 1. 4t equals, this is 4 over 1. 4t equals 2. Let me come over here. 4t equals 2. So t is 0.5, which is right here, 0.5 seconds. Do you see that? The general formula for when you use a sine function or cosine function for the x position of something undergoing simple harmonic motion, the number in front of the sine is the amplitude, and the sine function follows the general formula of 2 pi over t. We look at our equation. It's 4 pi, see over here. 4 pi, so 4 pi, right here, 4 pi equals 2 pi over t. So you set 4 pi equals 2 pi over t, and then just solve. All right, an object undergoes simple harmonic motion. This is the formula for its x position. What is the amplitude? Well, that's super simple because remember, you can use sine or cosine to describe something undergoing simple harmonic motion. If I look at this plot, I see that it starts at 1, which makes sense that you're using cosine because cosine is a function that starts at 1. So this amplitude is 1, but they didn't ask you for the amplitude. Oh yeah, they did ask you for the amplitude. So let's see. Oops, I'm looking. This picture doesn't belong to, obviously, that equation. I'm looking at this picture. So actually, the amplitude, like I said, is the number in front of the cosine or the sine, and that is 0.5. So that's pretty simple. The general formula for the x position is amplitude times cosine, the cosine of 2 pi over t, where t is the period, which they do not want. They just want the amplitude. So that's simple. Let's go back to this function over here. This is obviously a cosine function. It says the position of a function of, the position as a function of time for a mass oscillating a spring is presented by the graph, this cosine graph. Which of the following is true about the velocity and the acceleration at 1.5 seconds, which is right over here, 1.5 seconds? Well, that means that at 1.5 seconds, x equals 0. And what do we know? Let's look at this picture over here. At x equals 0, the velocity is at the maximum. And here, the velocity equals 0 at the full stretch of the spring. At either end, let's see, velocity at 1.5 seconds when x equals 0. Well, the velocity is definitely greater than 0. It's not equal to 0, so we can get rid of that. Actually, let's see. At one point, this is an interesting question. So is it greater or less than 0? Because sometimes it's going, when it's going to the left, it's a negative velocity. When it's going to the right, it's a positive velocity. Let's see. You're going from, let's take a look at this graph. You're going from a negative x position. So you're coming from this direction. So it's obvious, this is an interesting question. You're going in this direction because your x is negative here, right? When your x is negative, then your velocity, this must be going in the positive direction. Yeah, x is positive. Now the acceleration when the x is 0 is actually equal to 0. So v is greater than, let's see, right here. Yeah, v is greater than 0 and x. Well, we know that in the middle a is 0 because f net is 0. Let's write down equals 0 in the middle. So once again, why is v positive? Because before you get to 1.5, you've got a negative x. When your x is negative, you're heading to the right, and your velocity is positive. So this over here is the negative region. When your x is positive, actually, let's write this down. X is negative. Your velocity is positive. When x is positive, your velocity is negative. A nice little star around that one. So that is it. So we knew because on the way to that, getting to that 0, the x was negative, so the velocity is positive. That's why it's going to be, it's not this one because, of course, a does not equal 0. A is always 0 in the middle. So f net is 0 in the middle, so a is 0. So that was a good one. And that, oops, got another one over here. This looks like a sine function. What is true about the amplitude and the period? Well, the amplitude is obviously 1, so this is wrong. And the period is, what's the period? Time for one full vibration, which is this. So it is d right here. The amplitude is 1 and the period is, that's simple enough. Another sine function showing the x position. A is positive and negative 0.5, and the period is 2, because that's the time for one full vibration. Well, this one's an interesting. All right, what is this? Is obviously a sine. The x position is given by a sine function because it starts at 0. So let's cross this out, and we'll cross this out. Now, here's the deal. This is something you should always know. If the x is given by the sine function, the velocity is given by the cosine function. If the x is written, see, this is a sine function. If your x is described by a cosine function, your velocity is by a sine. Now, why is that? Well, the velocity equation always takes the form of sine, but keep in mind when the x is in a sine function, when x is 0, then x is 0, v is maximum. Isn't that true when the sine function is 0? The cosine is 1, and when the cosine function is 0, the sine is, let's see, is that right? When the cosine function equals 0, the sine, yeah, that would be 90 degrees, the sine function is 1. But just memorize this. Whenever your x equation is described with a sine function, let me fix this over here, your velocity, here, that's better. When your x function is given by a sine function, your velocity is cosine. When your x function is cosine, your velocity is sine. So let's take a look at that. We've got 3 choices. Let's see, what's the amplitude? 0.5. So this one's no good because this does not show an amplitude of 0.5. Now we're down to these two over here, and it looks like the answer is B, because when your x is described by a sine function, your y is described by the x is described by a sine function, your velocity is a cosine function. So the x and the velocity always have the opposite trig functions. If your x was described by cosine, your velocity would be described by sine. And let's go a little bit further. V is always 2 pi over t times, in this case, cosine 2 pi t. So let's go to the general formula of velocity. So since our x is sine, that our velocity would be a, takes on the general equation, a times 2 pi over t. In this case, the velocity would be cosine because the x is sine, 2 pi over t times t. So the a is, in this example, 0.5. So I'm running out of room. I'm going to go up top here. V is amplitude is 0.5 times 2 pi over t, 0.5. So the velocity is, ready, v equals a, which is 0.5 times 2 pi over t. Look at the picture in the period's 2 times cosine 2 pi, and again the t is 2 times t. So it turns out to be 0.5 times 2 is 1 over 2, and there's your 0.5 pi, and 2 over 2 is just pi, and there's your answer. And that's it for this worksheet.